Hello, in this video I want to give you an introduction into our paper Wide Area Multilateration Airspace Surveillance with unsynchronized low-cost ADS-B receivers using time difference of arrival observations. Many of you might know public service providers that display the airspace above you using ADS-B receiver networks. ADS-B is also an important part of the US NextGen and European CSAR programs for modernization of the airspace systems. But the ADS-B standard has no built-in security measures, which makes it, for example, prone to spoofing. A common solution is to use wide area multilateration to mitigate this. But the problem with classical wide area multilateration is that the clock synchronization is complicated and expensive. I now want to introduce our new approach that we present in the paper. The idea is to use an extended Kalman filter and estimate the relative clock offsets between the ground stations and the position and velocities of the aircraft at the same time. Observations that are taken into account are the TDOA measurements and the ADS-B message content, for example, the position of the aircraft. We perform multiple simulations to evaluate the applicability of the approach. I give you a brief introduction to the most important simulation parameters. We considered the German airspace and used flight tracks from the Open Sky network. Ground stations were placed in grids and in the largest cities. The receiver clocks were simulated based on a cheap off-the-shelf crystal oscillator. We performed a basic signal propagation simulation based on the signal range and horizon culling. Here I'm going to show you some of the results. In the two simulations that I present you, 40 ground stations placed in the largest cities were used, and we simulated a time of arrival accuracy of 0.1 microseconds, which corresponds to approximately 30 meters. In the left figure, only TDOA measurements were taken into account, on the right figure also the ADS-B position. In both cases, the latitude and longitude errors have a standard deviation below 20 meters. And you can also see on the right plot that the altitude benefits a lot from the absolute position observations due to the DOP. In summary, we demonstrate that under the taken assumptions, our approach is a candidate to implement a low-cost wide area multilateration network for secure airspace surveillance. If you're interested in details, check out the full paper, which is available free of charge, or contact me via email.